This week, the Planet Mechanics are playing with supersized blocks to solve an urban problem that is growing out of control. The answer could be contained in Liverpool. But even with an enthusiastic core of students,
We haven't really gone into that much detail.
will this giant experiment become a dream house or a heavy metal meltdown?
I look at those now and I think, whose idea was this?
Dick Strawbridge is an ex-army officer turned eco-warrior. Jem Stansfield is an inventor with a wild green streak. Two men on a mission to fix the world. One mechanical solution at a time. Together, they are the Planet Mechanics. Dick and Jem are on their way to Liverpool, a port city situated on the northwest coast of England. Once home to the Fab Four, and now European city of culture. Like many other UK cities, its population is growing fast, but the supply of affordable housing can't meet the massive demand. Across the UK, there's a current shortfall of 1.4 million affordable homes. Experts claim that new builds must increase by 33% a year. And Liverpool's 60,000 students are really struggling to find cheap housing. But the architecture students at the university think they may just have a solution. They've invited Dick and Jem to the city. It's their hope that the Planet Mechanics' practical expertise can help turn their theories into a real working prototype house in just a week.
These youngsters have got to be our future. They've got to come up with the bright ideas to solve this.
They are in a position to come up with really new ideas because they haven't yet learned about all the things that don't work.
Decent challenge.
Yeah.
This is it. We're in the university now, are we?
Professor Robert Cronenberg is the head of architecture at the University of Liverpool.
Must be Robert. Hi, I'm Dick. Great to meet you, Professor. This is Jem.
Nice to meet you. Thanks for coming. You guys...
He lectures in portable architecture, and he's hoping that there's one enormous eco-idea that will excite Dick and Jem.
How do you feel about containers?
Shipping containers.
Yeah, we're a port city. We've got loads of them.
Have you got some designs for using the containers?
Students have done some good designs, but we need some practical help.
Cool. We can do that. Do you want to show us what we've got?
Yeah, come on.
There are over 22 million shipping containers worldwide. 100 million container loads cross the oceans each year in over 5,000 ships. They're often too expensive to send back empty to their point of origin, so pile up at their destinations unused. Professor Cronenberg thinks they could make ideal building blocks for houses.
Now you have to look as if you're working, all right? The pressure's on.
The professor's students have already worked up a series of designs using containers as their starting point. They'll need to convince Dick and Jem that their ideas are realistic, especially as two of them must live in the finished house for a week.
This one's a 20-foot, this one's a 40-foot, and at the ends here, we've put the bedrooms.
The students have sketched out a simple design. They're planning to bolt the containers together like this, placing bedrooms at either end of the 40-footer with the kitchen and bathroom inside the smaller 20-footer.
Do you know how much power, electricity you need? How much sort of water you're going to be using? Things like that. Have that all been taken into account?
We haven't really gone into that much detail as of yet.
With no thought at all having been given by the students to the basics of heat, water and lighting, Dick and Jem may have their work cut out, trying to push them out of their ivory tower and into the real world. Dick also wants them to think even further outside their metal box.
We have the opportunity to actually make it an eco-living space, but, you know, as green as we possibly can.
Leaving the students with plenty to think about, Dick and Jem are anxious to get going. They've got a house to build in a week. Some containers and a place to put them is the first big job.
Catch you later, yeah? Thanks,
There are enough containers in existence to circle the Earth twice if they were laid end to end. Dick must hope that this means he can get a decent price on one.
Ian, nice to meet you.
Nice to meet you, Dick.
How you doing?
Ian Morris is a director of container care and a wily adversary. The average life of a container is 10 years. 1 million of them are retired out of service each year. Recycling some of these into housing could be a really viable proposition.
That's a decent, you know, it looks bigger on the outside.
Yeah, yes.
It's got a special smell, hasn't it?
A cargo smell, yeah.
So a bit of venting,
Yeah,
a
yeah.
bit of insulation.
Yeah.
This is a nice size, you know. You can see that, for, you know, it's bigger than most flats in London, isn't it?
Dick and Jem are trying to stick to a budget of £10,000, the average amount of rent paid by an undergraduate student over a typical 4-year degree course. So getting a good price on these containers is essential, since they don't know what other big costs are waiting for them further into the project.
What sort of price can you pick up a second-hand 20-foot for?
675 to
675.
plus the VAT.
Plus VAT.
Yeah, plus that, yeah.
Okay. All right, 40-foot.
40 foot, you're looking, the cheapest 40 I could do for you would be around about 700.
So if I want a 20-foot, can I take half a 40-foot? That's much cheaper.
That's my best price I give at the start.
So you don't do haggling?
Not really, mate, no.
You gonna look after me for transportation?
I will do, yeah. Yeah,
That's the deal.
deal.
After some very gentlemanly haggling, Dick and Ian settle on £700 for the larger container and £675 for the one-half its size. Not perfect, but not a disaster either, especially as the price of transportation is included. So, with Dick having done a deal on a 40 and a 20-foot pair of containers, all Jem has to do now is find somewhere on the university campus to put them.
We're not going to be able to bring the container up there.
I doubt
because
it.
I don't think we'll
might
get the truck
damage
up
the
there.
trees, mightn't you?
A university car park is the only available location which can provide the mains water and drainage that Dick and Jem will need. But there's a possibility that getting the larger 40-foot container onto this site may be tricky.
There could be a problem in trying to get the container truck round there and up this access road here.
With a 20-foot container already on its way, Dick suddenly gets a call they could all do without.
Yeah, I'm really pleased. I got a decent deal on a 40-foot and a 20-foot.
That's not quite as lucky as you might think.
Sorry?
You cannot get a 40-foot container lorry to get round the corners necessary to drop it here.
You are joking.
We have to get 3 20-foot containers.
3 20s. Okay, I'll see what I can do.
Oh, I'm really sorry, mate.
Dick has no option but to go back to Ian to renegotiate his prices.
Mate, this is going to hurt me more than it's going to hurt you. Change in plan.
Yeah.
Can't get a 40-foot container into the university.
Right,
You know,
okay.
the actual roads.
Yeah,
I'm going to need 3 20s.
Yeah, no problem, mate.
And if I actually say I don't really mind what they look like,
Yeah.
yeah, you'll look after me, won't you?
Yeah, I will do, yeah.
That's what I like to hear.
But with 20-footers being virtually the same price as the 40-footers, Dick's overall spend has just gone up from £1,400 to over £2,000. With the first container already on site and 2 more on the way, it's now quite clear that the students are going to have to radically rethink their designs, and fast.
We need some more plans from you now. Yeah. Time for a huddle. Run away, work hard, be fast.
If the Planet Mechanics are going to turn these rusting steel boxes into comfortable homes for £10,000 in just 6 days, they'll have their work cut out. Winter in the UK means fewer daylight working hours available. Dick and Jem now need a design blueprint fast. And in less than an hour, the students have come up with something.
Put your hand up if you're happy enough to carry on here with this.
Let's go. Yeah.
And just to see whether their small-scale sketches will translate into a viable design, a scale model is called for. On the right is the front of the house. This container has a door which opens into the main living space and kitchen. The top of the middle container will be the bathroom, with 2 bedrooms either side of it.
Thank you very much.
Okay, so I'm
That's
coming
nice.
through the wall.
Welcome.
You can
This is
hang
our-
your coats up and...
Our lobby / desk area, with study area.
I suppose the firm decisions that I'd really like to leave with would be what size openings we cut to join the containers, what the kind of offset is. If we can all just go, yes, this is it, and then before you know it, the sort of tapered carpet will become steel and wood.
Have we decided who's going to live in it yet? Or is that something that you're just waiting to see what it looks like first?
I'd live in it.
Yeah?
Yay!
That's one volunteer.
And Andy's going to as well, then.
Supposedly, if I can behave myself.
Yeah? So Andy and Therese, so you've got a vested interest in it now. Okay. You worried about anything, Jem? Just about all of it?
Well, obviously worried about every single detail, but I think we can work with this.
With a plan agreed on, it's time to activate the Planet Mechanics Eco HQ. It's a fully equipped workshop on wheels. Power comes from a solar panel and it's packed with all the tools and equipment they're likely to need.
Right, we got containers, we got a plan. What's next?
Well, at the moment, they're just 3 big solid metal boxes.
So we've got to cut the holes in them and join them together. That's no trivial task, is it?
No, because the holes going through to make them a big living space are going to have to be huge holes, which will then need reinforcing with big steel beams.
If we're going to do that work, it makes more sense to do it when they're separated, because cutting that metal, doing all that welding, give ourselves some space. We've also got doors and windows. It's a slightly more delicate job, but there's a lot of those to go in.
I personally fancy doing the big openings and the big steel reinforcements.
Well, in that case, I'll do the delicate little windows.
The students' design blueprint calls for almost entire sides of the containers to be removed where they all join each other, creating a single large interior space. Individual rooms will then be created by building stud walls inside it. With Jem now happy that he can get busy grinding and welding, a surprise visit from the professor halts him in his tracks.
Oh, you've got that bit. You've got that bit. And where else is the wall? There's no wall in it. It's gone.
You've still got the floor and the roof, though. You know, if you think of the container as like having 6 sides, it's only lost, you know, nearly 2 of them, if you see what I mean. It's still like...
It's like saying, well, we've got a brick, but we're going to take away 2 sides of the brick and still use it. If you did that for every single brick, you would be kind of saying, wow, is it worth using the brick? Before you start cutting, I would have a rethink. Because this is not like a normal house is built. This is a stress skin structure in which you can really make a hole anywhere. And it will still retain its strength. The only problem is you make the hole too big, the strength goes completely.
According to the professor, cutting out larger than necessary holes could seriously weaken the container's strength, possibly even resulting in a complete collapse. Having been convinced of this, Jem's decided to cut 2 smaller doorways in the sides of each container, instead of 1 big one. At twice the amount of work, this will take a lot longer. Dick, meanwhile, concentrates on windows and doors. 7 windows and 2 exterior doors have added a further £433 to the spend. With the supporting frame in place inside one of the doorways, while the rain still pours, Jem's keen to show off his handiwork.
All right, done?
Yep, that's the first opening done.
No.
What?
This container to join to this container.
Yeah.
We have this opening, and we've also got the bathroom opening, so it's 2 openings. Which means you're going to have to do all of this again.
The prof was dead keen, though, that we didn't start taking out big holes, because he said these things then lose their integrity.
Mate, from our perspective, if we're going to, in 1 week, join 3 containers together, we can't afford to make twice as much work doing it.
So what do you reckon? We stick a massive frame
Big hole, big hole.
And that's the seal, and then any doors then between the 2 are internal doors, don't matter.
If we don't seal it and the students get wet, our name will be mud.
All right, Dick, I'll rip it out and I'll put another one.
In Dick's opinion, there's simply not enough time to cut several door holes in each container. Jem cutting 1 large one instead is a much smarter idea. Or is it?
Maybe the professor was right.
No, because, well, yes and no. Once I put a beam across there, we've effectively made an I-beam at the top. It's all right.
I honestly believe it will be fine, as long as they don't have any roof parties.
Although the professor's warnings about the strength of the containers are correct, so long as Jem gets supporting beams in quickly, Dick's gamble will have been worth it, and time will have been saved. By the following morning, the previous night's hard work has paid off. The containers are now ready to be joined and then welded together.
Now we just want the steel goalposts to match up.
Dick and Jem have taken a real gamble on cutting out huge holes in the sides of the containers. Moving them needs to be an ultra-delicate operation. Moving them again could catastrophically damage their already weakened structure.
That's good.
That's good. Yeah, we can handle that, mate.
Keep going that way. Well, that's almost perfect. Lower it there. That's not far off at all.
So long as Dick and Jem's calculations have been correct, the large box section steel frames which support the huge holes cut into the containers should line up. Fingers crossed.
Perfect. Hey, listen, thank you very much indeed. Cheers.
Good work.
Thanks.
Wow. Who would have thought that?
At last, the three 20-foot containers are in position and the box frames all line up perfectly. So far, so good.
In you come, in you come, in you come.
What's the verdict? Hey, don't be shy.
Dick and Jem have deviated from the students' design and the professor's advice, and have cut out larger steel sections from the container sides. But will anyone notice?
I thought we were having like partitions and that.
Well spotted.
Minor part of it.
It was a bit of an economical decision on sort of time. Rather than have to match up a door and a framework, if you see what I mean, like a kind of walk through there, we thought if we cut the whole thing out, stiffen it, then match those two together, and then all we need to do there is put an internal door.
Partition,
Yeah. I think when you walk around in here, there's as much space as you could possibly imagine having with 3 shipping containers. So I think that's good.
Right, we can all stand in a circle and pat the person in front's back if we want to, but we've got work to do.
Now that stage 1 of the container house is complete, it's time for Dick and Jem to think about how they're going to create a sustainable home that people could actually live in.
We've got roofs, walls, ceilings, big spaces. What do we need to put into it?
All of them need light and heat.
Right, and we have to save energy in that. The lighting needs to be low energy.
Yep.
And any heat we put in, we're going to keep it in there with insulation.
Yeah. Now, the 2 really difficult rooms, I think, are the kitchen and the bathroom. Because the kitchen, we need water coming in.
Yeah, and obviously the waste going out.
Waste going out. And cooking.
Do students cook?
We've got to give them the facilities to cook. One day they're going to grow up and want to make a meal.
OK, and the bathroom, it's got...
Bathroom's potentially harder still, because it's not just water coming in
and waste going
and waste
out.
going out.
The waste from sewage is an issue.
Is sewage.
Where we are now, on a car park, sewage is a problem. It's going to have to be something like a compost toilet.
Compost toilets are ideal on sites where there is no sewage access. They're self-contained units which require no water, only regular handfuls of sawdust. Bacteria break down the waste, leaving fertilizer for the garden, and special venting makes them odour-free. Not cheap at £1,000, but for the lads, this is an ideal green addition to their ambition to make the house ecologically sustainable.
We give them solar panels so they can collect free energy.
The students living in there will get a real feel for what it is to be sustainable, as well as in affordable housing.
I love it. It's not just a big experiment, it's now a very big experiment.
Containers are constructed of different thicknesses of steel, 5mm floors, 6mm corner posts, and a very thin 1.5mm for the sides and roof. Hugely strong, but hopeless in terms of keeping the cold out and the heat in. The next stage is crucial: insulation. In the UK, £5 billion worth of energy is lost each year, much of it through poor insulation. More than 40% of the heat escapes through walls and lofts. In order for Dick to figure out what kind of material is the most efficient insulator inside a metal box, he's rounded up some students to line each container with a different product. First, Dick and student Ben are lagging container 1 in glass mineral wool. At £30 per roll, it's not the cheapest, but about 75% of it is recycled.
It gives a nice warm feel to that end.
It's quite warm doing it.
What do you mean? You're now an expert. 1 room later, you've probably laid more insulation than most people in Britain.
While Ben carries on lagging the walls of container 1 with the mineral wool, Dick needs to stay up to speed cutting and fitting the coated chipboard walls, all designed to retain as much heat as possible.
Right, how's that? Happy?
Yeah, not bad.
Jem and Stephen are cladding container 3 in thermohemp. Compressed thick hemp fibres sandwiched inside a reflective foil. Very expensive at nearly £40 per roll, but it is far less bulky than the other products.
Can I just say, this is the end you're living in, so make sure you get nice and warm.
Dick and Andy are using Eco Wool in container 2. 85% of this insulation uses recycled plastic bottles. It's the cheapest by far at £15 per roll, yet has extremely good heat retention.
All the rooms are going to have a similar air temperature. Which one do you see looking the hottest from the outside?
I've got to tell you, it depends how well you do it. If you leave any gaps, cold air comes through it. I personally think it'll be at this end.
Like you said, though, it's down to how well it's put in, so I'm going for this end too.
Dick has spent a total of £680 on insulation. When the house is complete, he's planning to put the 3 different materials to the test with a thermal imaging camera. But in the meantime, eco-curiosity has got the better of him.
Remember all those little gaps?
There is one source of warmth which might test the effectiveness of different insulations. Human beings.
It's lovely and warm, actually. Even in this lovely windy day, I can't feel the thing.
It suits you. Make this a proper experiment. Look at this, the man's nearly naked anyway. Now this is Eco Wool, recycled from plastic bottles.
It says it doesn't itch. This is what we're putting on the container. I'm getting drafts.
He's got drafts.
I think we're learning a lot here. In the interest of science, Dick and I are actually going to get on with finishing that.
Yeah.
But if you two could just sort of compare notes as to how the insulation's performing.
If you get a really cold scream, somebody's bound to come and help you.
Yeah. I think you look moderately more stylish, but with Christmas coming, you do quite well yourself. Just enjoy yourselves. Okay. See you later.
And to give the experiment real scientific credibility, Dick and Jem decide that a couple of hours is about the right length of time to leave the boys.
Okay then, real science. How are we doing? What's the verdict? Are you warm?
Warm, but a bit drafty in the places where it's folded over.
Okay, marks out of 10 for warmth.
7.
Warmth out of 10? Marks out of 10?
About an 8.
About an 8?
Oh.
So, yeah, it's more expensive, but it scores better.
Yeah.
Right, if you had enough, you two, time to do some work.
Yeah.
Okay, cool.
Come on.
Oh.
It's a new day. Now that the insulation stage has been completed, Jem cracks on with fitting internal walls and doors. Dick's curious about what his options might be for heat, cooking and power. Very few people live in self-sufficient metal boxes, but strangely, there are quite a few waterborne examples that may provide him with some ideas.
Roy, nice to meet you. How you doing?
Come on in.
It's lovely and warm in here.
Sandra and Roy's home is a canal narrowboat.
Would you like a drink?
A cup of tea would be lovely. Thank you. All the heat in here is coming from the little stove.
Yeah. No central heating, that's all it is.
Yeah. Well, and what are you burning in this, Sandra?
At the moment, we're burning smokeless coal.
Smokeless coal?
Smokeless coal.
Well, we're in a marina.
We're in a marina, just at the moment.
We can't, because wood isn't smokeless.
It's multi-fuelled.
The size of that kettle for the two of you. Look at that. You can have the whole marina in for tea or coffee with that one.
I can't lift it.
Just took a little bit of lifting, but...
It's serious. So that's your hot water supply?
That's hot water supply.
When we're not moving.
If we're not moving, but the engine does supply us with hot water as well.
Careful.
Thank you very much indeed. Boiled on the stove.
Boiled on the stove, you can't beat it.
Notice you have some solar panels. You've got all these lights. Are all the lights 12 volts? On the solar, and the solar panel charges your batteries up when you get enough sun?
Yeah. In the summertime, the amperage whips up. The batteries will charge up, and they'll give us enough power in the batteries to run the fridge, which is electricity, 12-volt fridge.
12-volt
so
fridge.
it runs that, runs the light, and...
Television and video.
Is that an oven?
That's my oven.
Had we known you was coming, we would have had
I'd have baked a cake.
A baked cake.
Thank you very much indeed. It's a lovely, lovely place to visit.
Seeing Sandra and Roy's wood-burning stove, solar panels and insulation working so well is encouraging. But to operate efficiently in a much larger space like a container is a different proposition altogether. But Dick is feeling inspired.
The wood burner. It's got a number of jobs to do. We got flames. Those flames are going to heat up some water for us. And what we're going to do is we're going to store all that hot water in a thermal store, a heat store. So we'll take water from here, we'll heat it up.
Dick's thermal store is a giant hot water tank heated by the wood-burning stove. A separate water pipe carrying cold mains pressure water coils its way through the hot water tank, delivering piping hot water at the other end.
That's ace. So you get cold mains water coming in and then hot mains water coming out.
Plus hot water from our pieces of wood burning. We also have the ability to cook on the top of this.
Yeah.
And it's sending heat out into the room. So we've got cooking, heating and hot water from a log.
Dick, that's a work of genius.
Dick's hot water heating system is an ideal eco-solution for the house. But if it's not fitted correctly, they could be sitting on a ticking bomb.
If it was to get over 100 degrees, we would have a problem.
I'm petrified of that whole scene. I really properly am. The potential disaster is so horrendous.
Absolutely. I agree entirely. You know, this closed circuit, if we were to make a mistake on this, it's a very big thing to crack and blow up and stuff.
In order to underline the danger of Dick installing a wood-burning stove and hot water tank himself, it's back down to the safety of the container depot to see what Jem's cooked up.
Hard hat.
I didn't have a good feeling about this. It's getting worse.
You'll need it. High vis, you might need that.
Jem.
Solid steel. Bulletproof plastic.
Oh, dear.
Thick wooden construction.
No, this is going downhill. You know that, don't you?
Tin of beans.
No.
Yes, this is the worst case scenario that I'm trying to set up here. I've got little solid fuel burning things.
Yeah, they're for camps. They burn very hot for little campfires.
Very hot indeed. I've put far too many...
There's a lot of heat in that, mate.
There's far too much heat in there, but that's like our wood-burning stove, OK?
Right.
This is like our back boiler. It's a thin-skinned metal container full of liquid. And now I'm going to sprinkle a few more of these around, just for extra danger. It's a very important experiment.
You're not going to light that, are you?
Of course we're going to light it. Right?
You are not joking. You got out of there quickly, didn't you, mate?
I did. What we're doing is phenomenally wrong, but sometimes in the pursuit of knowledge...
That's not clever.
When water gets above 100 degrees centigrade, it wants to become a gas. At this point, it expands about 1,000-fold and escapes from its container, like boiling a kettle. The can of baked beans is Dick's hot water tank. By not allowing pressure to escape from the tank by venting it correctly, the liquid inside cannot escape and become a gas. Eventually, the structure cannot contain the huge pressure inside it and must explode.
Nope. Get back a bit.
Do you know, I feel a little bit guilty. Oh, so I thought I was hiding behind you for a moment.
No, I'm hiding behind you.
How long do you think it's going to take?
I don't actually know, Dick.
What?
The theory is the liquid inside wants to become a gas because it gets so hot. It can't. The only thing that's stopping it is the bean tin. Eventually, the bean tin has to go. You can just see the ends bulging, though. And you know something's happening in there.
Oh, my God! Jem!
My life!
Hold on. You can smell beans!
Look at that, fella. It's just blown a seam
The
off.
whole end's just come off it, hasn't it?
Wow.
If Dick's hot water tank is not fitted absolutely properly, then it might suffer the same fate as the baked bean can. Not a happy thought.
Man.
Yeah, it's worthwhile investing in a professional installation.
With only half an hour to go before a team of specialist plumbers arrive to fit the wood burner and water tank, other essential utilities are starting to arrive. A very green compost toilet, shower and a combination kitchen sink with a fridge and stove unit that can run off mains power.
What do you reckon? It's a beautiful thing, isn't it?
Making the best use of the available space is uppermost in everyone's mind. Positioning the items that need electricity and plumbing close together is the starting point for everything else that follows.
Right.
OK, let's get a plan over here.
This is what Prof's kicking in.
The ideal position for the stove is right slap bang in the centre there.
The professor has had plenty of experience in small space design and is anxious to air his views.
Why wouldn't you want that to be on that wall?
And look out the window.
That's even nicer, yeah, you're right.
The problem is, time is running out.
Can I make a different suggestion? If you put that toilet in the way here, you're squeezing round the toilet. Can you take that all the way that way? Design is a discipline of negotiation. You should know this.
Whoa. But the most important decision of all has yet to be agreed on. The position of the wood-burning stove. Getting this right is vital. It needs to be close to the water tank it will heat, near the sink for convenience, and in the optimum place for its warmth to circulate efficiently.
And from my perspective, we spent all this time insulating the roof, putting in double glazed windows, making it a nice cosy space, but the stove has to be the heart of it now, doesn't it?
Yeah, it's a real architectural identity to have the stove in the centre of the house. The hearth is the centre of the home, and so you're absolutely right.
Home is where the hearth is.
Move the kitchen along here, put the heater here so it heats the whole area.
The advantage which may come from that is we may be able to put the hot water tank in the bathroom in that space we created.
That's a good idea.
Yeah.
The stove will be positioned here, in the living room. Its pipes will connect through a wall to the water tank here. This in turn will feed hot water to a shower, sink and kitchen unit here. This position should allow maximum warmth to spread around the house. Jem has convinced Dick that paying extra to get the water tank and wood burner safely installed and vented is worth the money.
This is the bathroom. You'll drop down there, Rich. Cheers, mate. This in.
While the students stockpile fuel they've scavenged from local skips, and the fitters get on with their job, Dick and Jem have the small matter of a huge solar panel to wire up and install. This is a big spend. 6 solar panels, 4 storage batteries and 5 LED strip lights add up to £1,786. Dick needs to make sure that the 6 110-watt panels are wired together in parallel so that they generate a combined output of 660 watts. This power will feed into the large storage batteries under one of the containers, which in turn will power the 12-volt LED lights inside the house.
Wow! Look at your solar panel system.
Done, mate. All the solar panels are linked together as 12 volts.
Yeah.
That's quite a lot of power coming in that.
Yeah.
I think we may need it this time of year. Right. Electricity's going to come down the red and black into the batteries. The battery's going to power the lights.
So light on the outside makes light on the inside?
Yeah, but the beauty is, sunshine during the day makes light at night. You don't have to take any weight at all, I've got it actually.
But with the panels bolted to a steel frame, it's now hugely heavy and will need all available people power to get it into position.
Hold on a second, mate. Hold on. Yeah, hear that?
Say that. Yeah, it's perfect.
Right, I'll wire it up to the batteries.
Great.
Thank you very much, assistants.
But with the light rapidly fading, Dick and Jem won't know until tomorrow whether or not the panels are working. With the water tank, wood burner and chimney now installed and a wall slotted in between them, it's time to fire her up.
All the way shut?
All the way shut.
It's done.
That's it, walk away, go. I just can't wait for it to be warm in here. How long would that have to burn for to get yourself a tank of hot water?
In the region of about 45 minutes.
So, wow, that is good.
That is very good.
Once you've got it up to temperature, not from cold.
If that's going 45 minutes, then that thermal store gets hot enough that you can just run mains water through and you just get hot water out the taps.
Yes.
Wow.
That's impressive, isn't it?
As well as being carbon neutral and fuel being cheap or free, modern wood stoves have a secondary burn feature that burn off the gases from the logs, making them highly energy efficient.
I love it as well. You can almost not have a telly if you've got one of them. I do. I think fires are fascinating to watch.
It's the last day. The solar panels are up and slowly trickling electricity into the batteries. But with shorter hours of winter light, it's unlikely that solar energy alone can give the house all the power it needs. Students need computers to work on, and Jem thinks that all that wholesome youthful vigour could power one of his technological favourites.
How we doing, mate?
Have you been skateboarding?
I've just been doing my heel flips and 900s.
Well, now you've finished, I probably need one of your wheels.
You are joking, aren't you?
No.
Human power.
Yeah, So the idea is the students pedal the exercise bike.
Yeah.
Then the flywheel on the exercise bike then goes whizzing round. Then I get my motor stroke generator. If I can fit one of your little sticky skateboard wheels on there,
Yeah.
I can push that against that flywheel, which is going to make my motor spin, generate electricity at the end of those wires, which I can then plug into a battery, and off that battery, they can power their laptops. They'll need to pedal this for probably 10 minutes to get half an hour's solidly laptop use.
For every 60 revolutions of the pedals, the bike's flywheel spins 600. In turn, the small wheel connected to the generator will spin 3,000. The electricity generated will be 12 volts DC. This in turn is fed into a battery, and from there to an inverter, which converts the charge into 240 volts of alternating current.
And then you need this if everything else fails.
Yeah, and it's like, it's a last emergency item.
Okay, you can borrow this, protect it.
Yes, thank you, Dick.
Building a house from scratch out of shipping containers in just 6 days is a huge undertaking. And there's a ton of work still to be done. Dick and Andy are trying to finish the walls and ceilings, now that all the insulation has been fitted.
Good man, let's stick them all down.
Meanwhile, before Jem gets going on the clever bit of his exercise bike, he needs to build a small table for the laptop to sit on. Every last thing on the house needs input from Dick and Jem, right down to locks needed for doors. The students, meanwhile, get on with something much harder, putting up curtains. Now that Jem has his skateboard wheel, he can connect it to the generator, salvaged from a golf buggy. With the connections made to the battery, he's more or less ready to go.
Is it all together?
That's just about done now.
Inverter?
Inverter's in.
Yeah, good.
In fact, if you could just monitor my pedalling to check that I'm generating the right amount of power.
Right. You're turning here.
Yeah, then that's turning that pretty quickly.
Yeah.
Which should be turning that at the right rate to generate the right amount of volts to charge that battery that will then power this inverter that will then power the computer.
Makes sense. That does make sense. So I can see how much you're doing.
Yeah. If I chuck the laptop on here, and just to make it a fair test, Dick, do you want to keep hold of the battery?
That's confident.
Well, you know.
Good effort. Right, hold on.
Now, I don't want to overcook it, so just only let me go up to a sensible quantity.
Well, 13.3, that's what I got, yeah?
Yeah, 14 even I'd settle for.
You better start pedaling, mate. You haven't got anywhere near enough there. You're less than 12 volts. Right, you're... Whoa, that's looking good. You've got to keep steady on that, because that's about 12 and a half.
Thing is, you get excited and you pop your voltage up.
Can you work like that?
Yeah. It sort of harks back to those days when the women used to, like, press their little treadle for their sewing machines. I think.
If you had this battery in there, this would be charging now, wouldn't it?
Yeah.
Good. But if I were you, I'd be saving your work regularly.
Save. Imagine that, losing a whole essay.
As evening approaches and work needs to continue, right on cue, Dick and Jem's solar panels start providing the power for the 12-volt LED lights. The incredible thing about these is that nearly all their energy is converted into light, not heat. In normal incandescent bulbs, it's the other way round. There should be enough electricity stored in the batteries to keep them on till the following morning. With the 3 containers each fully insulated with a different material, 6 double-glazed windows installed, and the wood-burning stove going strong, thermal imaging expert David Farmer is finally called in to measure which insulation material is performing best.
How's it going, David?
Okay.
Yeah, that doesn't look bad at all. That's nice and cool.
Can you see that there?
The infrared camera displays different temperatures as colours, red being the hottest and blue being the coolest. It's immediately clear where the containers are losing heat.
There's an awful lot of heat underneath it. What's
There
that
is,
about?
yes. Well, it appears that we're losing most of the heat, actually, from beneath the floor.
The floors of the containers are made of polystyrene sandwiched between layers of plywood, and neither material is providing any real insulation at all.
If we were to put down carpets and underlay, that would just stop all the heat coming through. Because you can see the big hot bit in the middle, that's the stove.
Yes,
Yeah,
yes.
and that's why the floor is so warm there. Okay, and the vertical line there?
vertical line there is obviously where the seam is.
We didn't put as much insulation there as we should have, I think. But that's okay. That's not very hot. It's just warmer.
Where the containers are joined to each other is also a problem area. The seams are not glowing red, but a cooler green, meaning there is definitely heat loss, but not nearly as bad as the floor. What's also clear is that even with double glazing, plenty of heat is escaping through glass.
Okay. What difference did you find between the containers?
Well, if you actually look across the 3 different sections that you've actually got, they're all looking reasonably the same. There's not a lot of heat loss through the container.
All right, because they're all different types of insulation, but they're all performing. We've got quite a lot in there in the walls.
With a considerable price difference between the 3 insulating materials, buying the cheapest, the Eco Wool is a smart move. But if saving space is an issue, then the most expensive but thinnest thermal hemp is the answer.
I'm pleased with that, you know. And do you know the other good thing about this? It is so warm because the stove's kicking out masses of heat.
Yes.
Talking of stoves, mate, it's much warmer in there.
Okay.
So with the house having been tested for warmth, the question still remains, can it stand the heat? There are around 40 lightning strikes on the planet each second. A metal house might be considered to be especially vulnerable to a 300 million volt bolt of lightning. Jem feels that the container house may require a radical safety test.
Dick, are you not a little bit concerned about building metal houses when thunderstorms strike?
I think it's going to be hard to sell it as an idea because people are a bit wary of thunder and lightning, aren't they?
Well, there's kind of 2 schools of thought. One, the worst possible thing you want to be next to in a thunderstorm is anything metal.
I'm with that 100%.
The other one is, theoretically, inside a metal box is the safest place you could be.
Theoretically?
Yes, theoretically.
Yeah.
But because we don't know, I think we've got to test this before we put anybody in to live there.
What do you mean test it, Jem?
Or we need an artificial lightning generator, like one of these.
So that's what it is?
Yes.
I just thought it was a son of a Dalek.
It's like a Dalek, only far more dangerous. Yeah. This thing can generate 1,000,000 volts, okay? So it gets it up, bangs 1,000,000 volts into the side of the container.
And you're going to go in there?
No, not necessarily me. But somebody's got to go in there and find out if they survive.
Paper, scissors, stone.
Okay.
1, 2, 3. Yes, I win. You're in there, fella.
Oh, Dick. If I
Jem.
don't survive.
Good luck. This is a bit scary.
Jem is standing inside a Faraday cage. Michael Faraday described the principle whereby an electrical charge, when fired at an enclosed metal container, will flow around it evenly and not penetrate the container. A bit like being in an aeroplane. Michael Faraday better have been right.
Yeah, all right, hit it, yeah. Jem.
Dick.
Good luck.
Yeah.
The Tesla coil takes 240 volts of mains power and transforms it into nearly 1,000,000 volts, equivalent to a small bolt of lightning.
Take your time, mate, just do that till you're happy.
Dick, if anything goes badly wrong, I love you.
If it all goes wrong, Jem might be swapping this metal box for a wooden one.
Oh,
Properly
Stay
alive.
in there, it's still live!
Do it more, do it more.
Oh. Brilliant!
Phenomenal! To be inside a box being struck by lightning has got to be one of my highlights.
It's safe. Students can move in any time.
Metal houses, Dick. The way forward.
With the addition of some finishing touches, like furniture, Dick and Jem's prototype house is finally complete. A week ago, this house was 3 rusting containers. Dick and Jem's original budget for this project was £10,000. So despite having to buy 3 instead of 2 shipping containers, they've also bought steel, timber, cladding, insulation, windows, doors, a wood stove, kitchen unit, shower, toilet, LED lights, wiring, switches, solar panels and furniture, and all for a grand total of £12,000, 2 over their budget. And on the plus side, the LED lights are running off the solar panels, all heat and hot water is coming off the wood stove, and there's even pedal power for the computer.
it's been really hard.
Although the students have been dead good, they've worked very hard, Robert's been very supportive, and we've nearly killed ourselves.
Yeah, but what have we ended up with? This is a nice bedroom. I love the fact that the lights come from solar panels creating the energy.
I think that's quite spooky, though, isn't it? You take sunshine and you make light.
Yeah.
How does that work? So, 2 bedrooms,
Hold on.
1 ensuite bathroom.
And the hot water comes from the back of the stove. That's nice, isn't it?
That's free. See, I think the wood burner was a brilliant touch.
Yeah.
The idea that you can get free heating and hot water, I love that.
This end is the hemp insulation. We've got the bottles, we've got the recycled. The whole thing's lovely and warm.
I find that interesting. You can't feel the difference in the insulation. If that end's warm, this end's warm. I think they're all dead good.
This is not a small house. And if you come into here, you don't think you're in a shipping container, do you?
That's what I was going to say. You
quite
call
like this. Hey!
You call it a house, and that's the weird thing. You stand in the car park, and there's 3 shipping containers, and then you step inside, and there's a house.
They've got a microwave.
Yeah. Then they can do their cooking on the wood-burning stove.
That's lovely, actually. I'm going to tell
It
you.
is.
I look at that and I think to myself, this is the heart of it, isn't it? Clever little fan, no electricity, and it's blowing the air. See, that's just helping all the air circulate around here, which is lovely. And you can cook, you can heat the hot water, and the wood's free. They're picking it up from the skips.
But before a house can become a home, it needs a party.
Is there anybody out there?
It's warm in here, don't be shouting. It's lovely and warm in here.
All of them.
Oi! Oi!
Andy, Therese,
Sorry? Oh, yeah.
the keys to your new house.
The married couple. Started great. How did I get volunteered to do this?
Well, thank you very much for a nice house.
One thing that's made me look at it differently, have you ever seen the film 7 Brides for 7 Brothers? Where they, like, build a house in a day.
Yes.
And I now can never watch that film.
The problem of affordable housing is an acute one. Dick and Jem and the students of the University of Liverpool have demonstrated that the idea of a shipping container home offers a genuinely viable and ecologically sustainable solution to this situation, not just here in the UK, but right around the world.
The Planet Mechanics takes another challenge at the same time next week. Coming up, it's part 1 of our brand new double bill on the Great Wall of China.